This is part 2 on our lesson 6.6 on the Pythagorean theorem. We talked last video about these perfect squares and how important this list is. This list is in your files section for channel 6.6 as a PDF. Really good idea to print this out if you're capable. Have these numbers in front of you when you're working on these problems. It's really, really important. So this section is on the Pythagorean theorem and its converse. And this is my favorite section in the whole course. Here's a standardized test practice question. There's a 16-foot ladder that's going to rest against the side of a house. So this ladder resting against the side of the house, it's 16 feet long. The base of the ladder is 4 feet away. So this ladder is 4 feet from this house. Approximately how high above the ground is the top of the ladder? So you want to know this distance. Hopefully you notice that this ladder, the ground, and the building form a right triangle. And you know this length of the right triangle, which is the hypotenuse, and you know this length of the right triangle, which is a leg. What you need to do is find this other leg. And certainly based on appearance, it looks like this other leg is the longer of the two legs. It looks like it's longer than 4 feet. Could this distance, x, be 240 feet? Well, the ladder is the hypotenuse of the right triangle. So the ladder has to be the longest segment in the triangle. So 240 feet does not make sense for an answer. Likewise, neither does 20. 20 is bigger than 16. Well, 16.5 is bigger than 16 as well, but 15.5 is not bigger. It's the second biggest side. That's why this one makes sense. Now, you don't know how to use the Pythagorean theorem yet, but that's what we're going to teach you in this section. We're going to show you the skills that you can use to actually calculate this distance. You're not going to have to guess or use process of elimination. Here's the Pythagorean theorem. You can only use it when you have a right triangle. And it tells you that if you take a leg and square it, and add it with another leg squared, it's always going to equal the hypotenuse squared. Always. So we're going to say a squared plus b squared equals c squared a lot. That's what the Pythagorean theorem is. But you got to understand that a and b are both the legs. You need to make sure that your legs are a and b. C is your hypotenuse. Okay, so we're going to do some examples with some numbers so it makes more sense. Here's a right triangle, and we know 2 of the sides. It's important which 2 sides you know. The Pythagorean theorem says a squared plus b squared equals c squared. The legs are these 2 sides. The hypotenuse is what you don't know. That's what you're looking for. You're looking for the third side of this right triangle. So since A and B are your legs, it doesn't matter which order you put them in. We'll say that A is this length of 20, and we'll say that B has a length of 21. Square both of those and add them together. And that's going to give you your hypotenuse squared. Now, if you refer back to your perfect square chart, 20 squared is 400. And if you don't have your chart with you, you can just type this into your calculator or your phone. 20 times 20 gives you 400. What about 21 times 21? It gives you 441. That's what c squared equals. So if you simplify that, you know what 400 plus 441 is. It's 841. 841 is a number squared. Well, we just want the number. We don't want the number squared. How do you unsquare again? Remember, you take the square root. Now, if you don't have a calculator, then you could just say that the answer is the square root of 841. Because that's exactly the answer. But if you do have a calculator, you can type this in and get the exact answer as a decimal as well. And that's what we're going to do here. I guess I'm just going to type it in. I was going to try to show you one here, but I don't really think I know how to do that. And what in the world did I do? It was 841. Square root of 841, right? Yeah. So you type into your calculator square root of 841, and it's going to give you an answer of 29. So this side has a length of 29. When this is 20 and this is 21, that must be 29. We use the Pythagorean theorem. Now, we can also use the Pythagorean theorem in an example like this. It's a right triangle. If we know two of the sides, we can definitely find the other side. Now, we called this side C because it was the hypotenuse. Well, the hypotenuse on this triangle is this guy. We already have it. So if you want to call that A, you can. You can call this B. We need to find B. A squared plus B squared equals C squared. Our A is 8. Our B, we don't know. Our C is 20. We want to get B squared by itself. So to do that, you're going to subtract 8 squared from both sides. So B squared is going to be the same thing as 20 squared minus 8 squared. And that might seem weird, but 20 squared is 400. We know that. And you know that 8 squared is 64. So B squared is going to be 400 minus 64. That'll be 336. That's what B squared is. So B is going to be the square root of that. Remember, that's how you unsquare a number. So is 336 a perfect square? It's not. If you look on your chart, 336 is in between 324 and 361, those perfect squares. So you know your answer is going to be in between 18 and 19. Okay, and that makes sense because 20 is the biggest. So 18 and 19 is definitely less than that. Okay, if we jump back over here, 29 was bigger than 20 and 21. That makes sense. That's the hypotenuse. Okay, so in your calculator or your phone, you're going to type in square root of 336. And it gives me 18.33 and then some other numbers. We're always going to round to the nearest hundredth. So we're going to keep 2 decimal places like money. So my calculator says 18.330. That's why I rounded to 18.33. And notice how that was a whole number and this one wasn't. That's okay. More times than not, when solving for the side of a right triangle, you're going to get a decimal for an answer. Don't panic, just check your work and trust yourself. Think about it. If you're finding the lengths of things, very rarely is it going to come out to be a whole number.